Alright, y'all, so picking back up with page 14, it says regression at the top. So this page is going to be a lot of just calculator work. Specifically, you'll need like a graphing calculator that has the stat function. I think you can, if you don't have one of these, I think you can Google like an online version of like a TI-83 and do it that way. I'm not positive, but yeah, it says, so given a set of data, the graphing calculator can be used to find the best fit equation. So if you don't have a graphing calculator, I would just watch. I'm going to do like one example. So just watch and try to see how I'm doing it so that if you have to do it yourself, you're able to. But it's pretty straightforward. So it says here, so there are different models that you can use for a set of data. So to determine the best fit equation. So you can have linear, quadratic, cubic, quartic, exponential, and logarithmic. So depending on the set of data is which model you will use. And lucky for us, it tells us in every problem which model to use. So it's pretty straightforward. You just have to know how to do it, which I'm going to walk you through. So I'm just going to start with number 1. So on your graphing calculator, the only area we're going to be using here is this stat button. So it says the table below shows the monthly sales in thousands for a new bakery after its grand opening in April. Use a quadratic model. Find the equation for the curve of best fit. So pretty much it's an equation that we're going to find that's going to best show us that data represented on a graph. If it were to go like infinitely. Right now we only have 5 different months. But if that were to continue over like 12 years, this equation is going to give us a general equation for this set of data that never ends, and that you can plug in a value in any random day and then get an output for the number of sales they had. So, quadratic model. So I'm going to go up to this bullet here that says common model. So it says the quadratic is in my calculator. It's the 5th one down. So I'll show you what I mean. First, we have to put all this data into our calculator. So go to stat and then edit. You'll have these 2 columns here, and I've already put in the first question. So this one is only slightly tricky because the months are not numbers. So if you see for my first column, I just put 1, 2, 3, 4, 5. You could probably do 0, 1, 2, 3, 4. I was not quite sure. The rest are straightforward. So that's why I'm doing this one. And then in the second column, you put the corresponding sales. Okay, so after you do this, you find the model that you need to give you your equation. So it says a quadratic model, and it says that is 5. So what that means is, once these are in here, click stat, then go over, and you have all these different regression equations. So the 5 here is representing the quadratic one. So I'm going to click on that one, click enter. It gives you all the information you need. It gives you the form of the equation that you're going to be using, and it gives you the A, B, and C that you plug into that formula. Okay, so looks something like that. These numbers I got. So it says that find the equation for the curve of best fit. That's my equation. And then it says estimate the sales in December. So what that means is if it's, so this table right here, these are like my X's, and these are my Y's. So if it wants me to know how many sales were in December, well, I'm going to count. So I said April was 1, May, June, July, August, September, October, November, December. So that would be 9. I'd plug in a 9 into the X, and then I'd see what it gives me for my Y. So I plug in a 9 for all these X's and then see what it gives me back out, and that'll be the sales because those are my Y's. And it's the same process for the rest of them. You'll find the equation, and then you'll plug in an X value and see what you get for the Y. And that's why these regression equations are so cool, is that you can find information about that set of data for data that you aren't even seeing there. So since those equations are so general, you're able to do that. You can plug in an X and get out a Y and find out a lot of different things about that data that they didn't even tell you in the question. So that's all you're doing for 1 through 4.